Okay, in this video we're going to do 3.3 implicit differentiation. So implicit differentiation is needed when variables are related by an equation rather than a function, and we wish to determine the rate of change. And don't forget, the rate of change is just a derivative. So this is just the derivative. So on this line, right here, I would write the word derivative. Okay? Okay, so what do I mean about an equation, about variables being related by an equation rather than a function? So right here is an equation. And see how you have your y embedded inside the equation? Well, whenever your y is embedded like that, or if it's raised to a power, you're going to take the derivative using implicit differentiation. So this is this circle. So I can find the slope of a function drawn to this, of a line drawn to this surface, just like I do functions. Okay, this is not in a function, right? This is just a relation. Okay, let's go to the next slide and we'll start this work. Alright, so I've written down the steps that you need to know when doing implicit differentiation. So leave those steps right there, and I'm going to go through the problem, and then you can look at the steps in light of what I've done with this problem. So our problem is x squared plus y squared equals 16. That's our equation. I want to find dy dx. Now remember, the whole notation dy dx tells me that y is a function of x. That is critical. Keep that in mind throughout this procedure. Okay, start taking your derivative, work from left to right. The derivative of x squared is just 2x plus. Now, take your derivative of y squared. You get, using the power rule, 2y. But then, because y is a function, you have to write dy dx because you need that derivative as well. It's just like doing the chain rule, only now you're doing the chain rule on the y function. And then that's going to equal 0 because the derivative of a constant is 0. Okay, our goal is to get dy dx, which is right here. We want to get this by itself. So the first thing I'm going to do is undo this addition. I undo that addition by subtraction. So I'm going to say subtract 2x from both sides. That's gone. It's gone there now as well. It's over there instead. Next thing I'm going to do is divide by 2y. Divide by 2y. That's gone. Divide by 2y. That leaves me with dy dx equals negative 2x over 2y. I do not need the 2's, so my final expression is that dy dx equals negative x over y. Now that we've done that, go back and look at the steps that I employed in order to find dy dx by using implicit differentiation. We're going to continue this on the next page. Okay, I want to take a moment to talk about this circle. So look at the problem. It says take the circle above and find the slope of the curve drawn to the circle where x is 2. Okay, so x is 2. Here, right, whoops, I can't really draw it on my figure, right there, and also right here. So there are two places where x is 2. So you really could get two equations. We're going to concentrate our work for this purpose just in the first quadrant. So I'm going to restrict us to the first quadrant just for ease of demonstration. But you know you can get two equations because there are two places where you have a tangent line to the curve. Okay, and I just cannot draw that other tangent line because of the limitations of the screen. But you know that there's another one up here as well. We're going to focus in on the top one. I have listed out all the steps. It's the exact steps that we just went through. So I'm going to limit my discussion to just talking about what is this tangent line looking like. Okay, so let me go to the next slide to do that. Okay, so I've written out all the steps, and you've seen me do up to here. Okay, that's what we know so far, that the derivative with respect to y, when you're doing implicit, ends up being negative x over y. So what is this? This is slope. But notice something. In this situation, in order to tell me a number for the slope, I need both the x and the y to tell me that number. So that's the first time we've had that situation. So the last thing we're going to do now is actually get the tangent line. So to know how to get the tangent line, clearly whenever you see find the tangent line, I always want you to write this down. Okay, we know that x is 2. So x is 2, that's going right here. Okay, what is our y? Well, what was our equation? Our equation was x squared plus y squared equals 16. So to get my y, I'm going to plug in my x. So my x is 2. So that's going to end up being 4 plus y squared equals 16. So y squared equals 16 minus 4, which is 12. So y is going to equal radical 12. But if I do radical 12, can't I also write that as 2 root 3? And I would expect that you can simplify. So 2 root 3 is going to be my y value. That's going to go right here. That's why I have it here. So all we need now is the slope. Well, what's the slope? Here is the slope, negative x over y. So your x is 2, so negative 2 over your y is 2 root 3. The 2's can cancel. Your slope, without it being canceled, without the 2's canceling, is this. That's your equation of the line. So let's think about this for a second. Remember when we drew our circle, and this is a modified circle, we had the tangent line that we just found is here, assuming that this is going to be 2. There's another one. How is that going to be different? So let's think about that. Will the y value be different? Oh yes. Will the slope be different? Oh yes. How will they differ? So let me just do one thing here, because I'm going to write it right here, and we'll figure out what the difference is going to be. I have the same x, so far I still have x minus 2. Okay, my slope. What about my slope? My slope will still be negative x over y. What about my y? When I plug in for y, and remember this step right here, I only gave you half the picture when I was doing this step. When you take the square root, you actually get plus and minus, don't you? Here's the plus right here. Here's the minus right over here. So really, I had 2 answers. If I had not restricted you to the first quadrant, then I would have to have 2 lines. So to get the other line, the other y value is going to be a negative 2 root 3. Therefore, I can write y plus 2 root 3. And that's going to make my slope a positive. So it'll be positive 2 over 2 root 3. And then I would cancel the 2's. Doesn't that seem to make sense? This slope here is negative. My y value is positive. This slope here for this tangent line is positive. My y value is negative. So you should have a good understanding on how that works. Okay, on the next slide we'll do a couple of more practice problems. Okay, here's our first problem right here. So if I want to take that derivative, I want to find dy dx. So that's going to be 3x squared plus 3y squared. Don't forget you've got to say dy dx because y is a function of x. Minus 0 equals 0. Okay, so basically that's going to equal 0. So our goal again, as it is going to always be, is to isolate dy dx. So let's see if we can do that. I'm going to talk it through with you, but you should be able to do this on your own at this point. So I'm going to first move the 3x squared to the right-hand side. When I do that, I get negative 3x squared. Okay, so then I'm going to divide by 3y squared. 3y squared. Then I'm going to cancel my 3's, and my dy dx will be negative x squared over y squared. So again, to get the slope of an equation, to get the slope just in general, you're going to have to plug in both an x and a y. Okay, so let's play around with this. Look what I have here. I have function times function. That's going to be product rule. All right, just like we would do normal product rule, we're going to do it here. So I'm going to say left, so that's x squared, d right, 3y squared dy dx plus right y cubed, do not write dy dx, I have not taken a derivative, times the derivative of the left, which is 2x. Okay, and then equals 6, but that's just equals 0. So this equals 0. Okay, so what's going to happen now? So I'm going to get my pink out again, and my goal is to get this all by itself. So I'm going to move this term first. So when I do that, I'm going to get equals negative, I'm going to bring the 2 in front, 2x y cubed, and I have on the left now, I'm going to change the order, 3x squared y squared dy dx. Okay, let me just get rid of this for right now so we can keep going. Okay, so I want to get dy dx by itself. I'm getting closer. So divide both sides by whatever is attached to dy dx. So I have negative 2x y cubed. Divide that by positive 3x squared y squared. And that's what dy dx would be. But I'm going to simplify that because that's only appropriate. So at this point, this is an incomplete answer. Look at your x's. This x cancels that power. Look at your y's. This cancels that power. My slope is simply negative 2 over 3x, and I need a y up top as well. So negative 2y over 3x. Okay, on the next page, we're going to do a whole problem determining slope, and then we're probably going to end up drawing an equation of the tangent line. So let's do that on the next page. Okay, so it says use implicit differentiation to determine the slope of a graph at a given point. So they gave us the point, all right, and now I want to get the slope. So slope is the first derivative, it's dy dx. So look at my equation. I have y squared equals 3xy minus 5. So take my derivative on the left-hand side. I get 2y dy dx, because whenever I take a derivative, I have got to say dy dx when I'm taking the derivative of the y, because the y is a function of x. It's just like doing the chain rule. That equals, oh dear, look what I have. I have a product rule right here because I have function times function. So I have to say left, so 3x, d right is 1 dy dx plus right y, do not write dy dx, I have not taken a derivative, d left, which is just 3, and then minus 0 because 0 is the derivative of 5. Alright, now we have an interesting situation. Look what we have. We have dy twice. All that means is that you're still going to work to get the dy's on the same side, and then once you do that, you're going to factor. So let's work that through together. so let's move the 3x dy dx to the left. So that ends up, I'm going to scoot this over, 2y dy dx minus 3x dy dx equals, and I'm left with 3y. Okay, so, because I've taken the derivative, I'm now just moving things around. So don't retake any derivatives. Okay, look at the left-hand side. Do you see how you can factor out a dy dx? Because it's in common to both terms. So take your dy dx, take it out of both, 2y minus 3x, and then that's going to equal 3y. So you can probably see what I'm going to do, but I'm going to do it on the next page because I want to talk some more about it. So let me move that over. Okay, and I'm going to get rid of this little thing here and this little thing here, right? Those were not in that problem. Okay, so this is what I have. So therefore, I can say dy dx equals 3y over 2y minus 3x. Okay, that's what my derivative equals. Now, look what they've asked me to do. They would like me to evaluate this, and I'm going to do this by using the vertical line at x equals 2 and y equals 2. Okay, that notation's important. So you're going to plug in 3 times 2, 2 times 2, minus 3 times 2. Okay, what does that equal? Well, 3 times 2 is 6, and then I have 4 minus 6, which is minus 2. So it looks like this slope will be minus 3. Alright, so I've given you a lot to think about. I would go back, make sure that you could do those 3 problems that are on this last page by yourself, and that you're comfortable doing the product rule when you have a situation with implicit. Be comfortable doing the quotient rule also. In fact, why don't we just go ahead and do that on the next page. So I'm going to go one more page, and why don't I say x squared over y cubed equals 6, and let's see how far we get with this. Okay, so I want to see if I can find dy dx. So low d high minus high d low, it's going to be 3y squared, and then dy dx all over y cubed equals, the derivative of 6 is 0. Okay, so looks to me like I only have one dy dx to worry about. Alright, so here's my only one. I need to isolate that. So what will I do? Well, it looks to me like I can do cross products and get myself started. So cross products, I get the this numerator times 1 equals the denominator times 0. So what does that get for me? So I'm just going to clean this up as I go. So 2x y cubed minus 3x squared y squared dy dx equals 0. Do you understand why that's the case? Okay, so make sure you're getting the algebra of this. Okay, so I'm going to move this again to the next page, and we will continue to isolate. Okay, so we just need to get rid of, we'll get rid of this little guy here. Okay, so what comes next? I'm going to move this term over to the left. So I'm going to get 2xy cubed equals and I have 3x squared y squared dy dx. Okay, divide by 3x squared y squared, divide by 3x squared y squared, and I get that dy dx equals, okay, let's clean this up. 2/3 is fine. My x is left on the denominator side, and my y is left on the numerator side. And this is what dy dx looks like. And once you have your derivative, we can do equation of tangent lines and all the things we normally do with our derivatives. So that's it. So you should be able to go back, make sure you can do this, look at our textbook, and then be ready to do some more practice.